right, we're going to take some of the things we've been doing with angles, circles, and rotations and apply them to things you've done in the past, related to geometry and proportions and that sort of thing. And we're just going to go through several examples of different types of problems you might see, starting with this one. It says find the length of the arc, and the arc it's talking about here is this bolted in arc around the outside of the circle. And it tells us that this arc is created by this 135-degree rotation, and that the radius of the circle that we're dealing with is 8 yards. So to find the actual length of the arc, we're going to set up a proportion, and the proportion is going to be degrees to distance. So what I mean by that is we're going to take 135 degrees over 360. So the number of degrees of this arc over the total number of degrees for the whole circle. Then the second fraction of our proportion is going to be the actual length or distance. So it's going to be the length of the arc, which we don't know, which we're looking for, over the entire length of the circumference all the way around the circle. So circumference is 2 times pi times the radius. Our radius is 8. So it'd be 2 times pi times 8, or 16 pi. I would leave it as 16 pi. Don't like approximate or use 3.14 or anything like that. So we got x over 16 pi. So 135 out of 360 is going to be equal to x out of 16 pi. All right, so now to do this, to simplify this, we would cross multiply the 16 by 135. But actually, before I do that, that's going to give me big numbers. I don't want to waste your time by multiplying 16 by 135. So I'm going to simplify my fraction first. 135 and 360 actually both divide by 45. And 135 divided by 45 is 3. And 360 divided by 45 is 8. So it ends up simplifying to 3/8, which is pretty nice. Now I will cross multiply. I will take the 16 pi times the 3, and I will get 48 pi over 8 equals x. And then I will divide 48 by 8, and we get 6 pi equals x. And even if you weren't able to simplify that, I mean, feel free to use a calculator on this if you need to. It would still work out to 6 pi with the bigger numbers. So 6 pi is the length of my arc that I'm looking for. So that's how you do it. It's all about setting up proportions and using these geometry formulas. So let's keep going here. It says this time we got to find the measure of the angles. It wants the measure in radians. Again, this is going to be about setting up a proportion. So now we know the length of the arc it creates. The arc is 14 inches long. So setting up a proportion, we're going to say theta, that's the angle we're looking for, out of the entire distance around the circle, or the entire rotation. And since we're in radians, instead of doing 360, we're going to do 2 pi. So theta, the thing we're looking for, over 2 pi is equal to 14, the length of our arc, over the entire circumference of the circle again. So we have our radius is 12. C is 2 times pi times the radius. So 2 times pi times 12, or 24 pi. So 14 over 24 pi. This time to work it out, I'm going to cross. I could simplify again. Let's simplify. That would work better, wouldn't it? So I'm going to divide both of the numbers on the right-hand side by 2. I'll get 7 over 12 pi. Then I'll cross multiply this 2 pi. And theta will be equal to 7 times 2 pi, or 14 pi, over 12 pi. The pi's cancel out, and then theta is equal to 7 over 6. Now, 7 over 6 might seem like a weird measure for an angle, but remember we are in radians, so that does actually seem pretty reasonable. So that is the measure of that missing angle. Again, we do it with a proportion. Part over the whole equals part over the whole. This time we've got to find the radius. So we know the length of the arc and we know the angle. We don't know the radius, and we don't know the circumference of the circle either. And actually what we're going to end up doing is figuring out what the circumference is and then working backwards to find the radius. So here's what we're going to do here. We have 40 degrees. We're in degrees again, and we're going to set up a proportion 40 out of 360. And that is going to be equal to the length of our arc, which is 20 pi over 9, over our circumference. So remember, we're finding the circumference right now. We're not finding the radius. We got to figure out what's the distance all the way around the circle first, and then we'll work from there to figure out what the radius is. So I'm going to simplify my fraction. 4 over 360. That simplifies to 1/9. And we got 20 pi over 9 over the circumference. So now I'm going to cross multiply both ways here. And again, when you decide what you're cross multiplying where, I mean, the objective is to get your variable by itself on one side of the equation. So you want to do whatever will accomplish that. And here, if I multiply c times 1, I get c equals 9 times 20 pi over 9, which works out really nicely because my 9s cancel out. So my circumference of this circle is 20 pi. Now I've got to find my radius. Well, circumference is 2 times pi times the radius. In this case, my circumference is 20 pi. So to find the radius, I would just divide by this 2 pi. Pi's cancel out, I get 10 for my radius. So my radius is 10. So again, it's just a proportion. It's just cross multiplying things you've done before, and just using the circumference formula. Again, that's something you learned a while back. It's just a matter of putting it all together with stuff we're doing now. Next one here is the area of the sector. So a sector is a two-dimensional piece of the circle. It's like a piece of the pie, and we have to find its area. And again, this is going to be a proportion. And we have an 80 degree arc here, an 80 degree angle. So we're going to do 80 degrees over 360 equals, then we have our area of our sector, what we're trying to find out of the area of the whole thing. So you have to be really careful about whether you're using area or circumference. So here we're using area. Area is equal to pi times the radius squared. So our radius is 4, so pi is equal, or area is equal to pi times 4 squared, which is 16 pi, which came up earlier. So it's x over 16 pi. All right, so now I'm going to simplify my fraction. I can divide 80 and 360 both by 40, which should give me 2/9 equals x over 16 pi. And I'll cross multiply using that 16 pi. And I will get 32 pi over 9 equals x. So the area of my sector, and if you wanted to plug this into a calculator and get a decimal approximation, you could do that. But it's 32 pi over 9. And because it's area, I haven't really been putting units on any of this, and some of them haven't even had units to use. This one has feet. So I'm going to do feet. And because it's area, it's going to be feet squared. Area is always a square unit. So the area of that blue sector is 32/9 pi feet squared. So again, it's just another proportion. It's just cross multiplying again, this time with the area formula. So it's just a matter of recognizing what you're looking for and setting up a proportion that will help you find that particular measurement. All right, this one here does not give us a picture. It says find the length of an arc that subtends. So that's an interesting word we're going to talk about here. A central angle of 2 pi over 3 in a circle with a radius of 9. So what I want to do is draw a circle with a radius of 9. That's probably a little too long for a radius, but we're going to go with it. And it says that the central angle. So a central angle is an angle that has a vertex at the center of the circle. And it says its measurement in radians is 2 pi over 3. So that would be somewhere in here. So this is going to be 2 pi over 3. And I want to find the length of the arc. It says the arc that subtends this angle. So what that means, it's the arc that is created between the 2 points where the angle intersects the outside of the circle. So it's this area I'm kind of darkening in over here. I guess I could have used another color. But we're trying to find that arc that is created by that angle. And we'll call it x. And so what we're going to do is the same thing we have been doing. We're going to create a proportion. We're going to take our angle, 2 pi over 3. And since we're in radians, we're going to put that over 2 pi. Equals. And then we have our unknown. We have the length of that arc that we don't know yet over the entire circumference of the circle. So one thing to look for is just if it says length, especially like length of an arc, you're dealing with circumference. If you are dealing with area, it will say area. Otherwise, if it's a distance or a length, you're talking about circumference. So our circumference here, 2 times pi times the radius, which is 9, or that's going to be 18 pi. So we have x over 18 pi. And there's probably some simplifying I can do, but I'm just going to go ahead and cross multiply this stuff. I'm going to multiply 18 pi times 2 pi over 3. All of this is divided by 2 pi. And I can do a little bit of simplifying here. I'm going to cancel out these pi's. I'm going to take the 18 divided by 2. That's going to give me 9. And so now I'm going to have 9 times 2 pi over 3. I've completely canceled out the bottom of that fraction. So 9 times 2/3 times pi. Different ways you could do this. I would take 9 times 2 is 18. 18 over 3 is 6. So this would be 6 pi. So the length of that arc is going to be 6 pi. The nice thing is, especially with the problems in the book, a lot of times things might look ugly at first, but once you start working it out, stuff will cancel out, and you'll get an answer that's much, much friendlier looking than the equation you started with. All right, one more. The area of a circle is 80 centimeters squared. Find the area of a sector that subtends the central angle of pi over 4. So here's the thing with this. I don't know the radius. I just know the area is 80. Pi over 4, that's something like that. So this is a pi over 4 angle. And I want to find the sector. I want to find the area of this little piece of the pie. And all I need to know here is the area of the circle. I don't need the radius to figure this out, since what I'm looking for is not a distance, it's an actual area. So I'm going to set up a proportion. I'm going to say pi over 4, that angle, and we're in radians, so it's going to be pi over 4 out of 2 pi is equal to x, the area of that sector, over the total area of the circle, which is 80. And I am going to do the same thing here. I'm going to multiply the 80 up here. So I have 80 times pi over 4 divided by 2 pi. Now, there's no one way to do most of these problems, and you can work these out totally different ways and get the correct answer. What I'm always looking for is what's the easiest way for me to cancel things out, so I'm going to get something that's nice to work with. And so one thing I see I can do right away, I want to get rid of this fraction on the top, because I don't like fractions inside of fractions. And I see I've got an 80 here multiplied by pi over 4. So the 80 and the 4 are going to simplify. I can divide those both by 4. I get 20. And then the 4 cancels out. So now this is going to give me 20 pi on top over 2 pi equals x. And this works out really nicely because my pi's cancel out. I have 20 over 2. That's 10. So 10 equals x. So the area of that sector is 10 centimeters squared. So in a way, this is kind of a review of stuff you learned in previous classes. It's just tying it in with radians and with rotations and with the circles we've been working with. So hopefully those examples are helpful, and we'll get you through this next assignment.